Imagine you are trying to fix a broken appliance. You have a manual, but the instructions are vague. You try one thing, it fails. You try another, and the machine jams. Now imagine having a helper that does not just read the manual but actually understands the machine. This is the gap we are talking about with artificial intelligence. For a long time, models were like very smart readers. They could tell you how to fix the appliance, but they could not touch the tools. They could not turn the wrench. The Qwen3.6-Plus model represents a shift away from that limitation. It is designed to be a real-world agent. This means it does not just generate text, it generates actions. But having the ability to act is different from having the ability to act reliably. In a controlled environment, an agent might succeed. But the real world is messy. This is where the stress test methodology comes into play. We are not just asking the model to perform a task once. We are asking it to navigate a legacy environment. Think of legacy systems as old machinery. They have rusted parts. The connections are loose. The protocols are outdated. When a new robot tries to work with this old machinery, things go wrong. The robot might send a signal that the old machine does not understand. The connection might drop. The signal might be corrupted. The specific challenge for Qwen3.6-Plus is handling these failures without human help. In the past, if an automated script failed, a human engineer had to step in to debug it. This created a bottleneck. The promise of this new model is that it can detect the error, analyze the context, and attempt a correction autonomously. This requires a level of reasoning that goes beyond simple pattern matching. It requires understanding cause and effect in a dynamic system. To understand how this is possible, we have to look at the underlying architecture. The Qwen ecosystem has been evolving rapidly. The foundation here is the Qwen3 series. These models utilize a mixture of experts architecture. In plain language, this means the model is not a single giant brain. It is a collection of specialized sub-networks. When a task comes in, the system activates only the experts needed for that specific job. This makes the process more efficient. It allows the model to handle complex reasoning without slowing down. For an agent, this efficiency is critical. When a tool call fails, the model needs to think quickly. It needs to decide whether to retry the call, switch to a different tool, or ask for clarification. The Qwen3.6-Plus model integrates native support for advanced agent frameworks. These frameworks include Model Context Protocol and Retrieval Augmented Generation. These are technical terms for ways the model can access external information and maintain context over long conversations. It allows the agent to remember what happened 5 steps ago when it is trying to complete a task that takes 20 steps. Consider a scenario where the agent needs to update a database while also sending an email to a client. If the database connection times out, a standard model might just report an error. A stress-tested agent, however, checks the logs. It determines if the timeout is temporary. It might wait a few seconds and try again. If the email server is down, it might queue the message and proceed with the database update. This orchestration is what defines a real-world agent. It is not about executing one command perfectly. It is about managing a workflow that has multiple points of failure. The stress test methodology focuses heavily on this orchestration capability. Researchers simulate unstable network conditions. They introduce latency. They drop packets. They return error codes that the legacy application programming interface does not expect. The goal is to see if the model can recover. In these tests, the Qwen3.6-Plus model demonstrates a hybrid reasoning capability. This combines deep logical analysis with practical execution skills. It does not just think about the problem, it acts on the problem. This shift is significant for production-grade AI. For years, we have been told that AI is coming. But for AI to be useful in business, it must be reliable. If an AI agent fails during a critical transaction, the cost is high. The ability to operate without human intervention reduces that risk. It allows the system to self-heal. This is the transition from static language models to dynamic, autonomous agents. The Qwen3.6-Plus model is positioned as a preferred open-access foundation for building these systems. The evolution from Qwen3 to Qwen3.6-Plus indicates a future where AI systems will prioritize these hybrid reasoning capabilities. We are moving beyond simple text generation. We are moving toward systems that can interact with the digital infrastructure of the world. This includes terminal-based and browser-based autonomy. The model can navigate a user interface just as a human would, but with the speed of a machine. It can fill out forms, click buttons, and verify data. However, this capability brings new responsibilities. If the model can execute actions without human intervention, it must also have safeguards. It must know when to stop. It must recognize when a task is outside its scope. The stress test methodology also evaluates these boundaries. It checks if the model hallucinates actions. It checks if it respects the constraints of the legacy environment. This balance between autonomy and safety is the core of the real-world agent challenge. As we look at the trajectory, the consensus is that the Qwen ecosystem is rapidly advancing real-world agentic performance. Through efficient mixture of experts' designs and executable environment training, the gap between simulation and reality is closing. The specific architecture of Qwen3.6-Plus supports this by enabling seamless terminal-based and browser-based autonomy. It is becoming a preferred open-access foundation for building production-grade AI agents. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.